to Biostat_Squid. In the last few videos we talked about density plots, Violin plots and box plots. Now it's time to put all that theory into practice and create our own plots in R. In this tutorial we will learn how to create and customize Violin plots in R. We will use the R packages tidyverse, which includes ggplot2, or Color Brewer and Reshape2. As always, you can find the code I'm using in this tutorial at biostatsquid.com, where you can also find a step-by-step explanation of the code, or you can just get the entire script from Biostatsquid's GitHub page. I'll be using RStudio and data from the R package datasets, which should be already installed if you have the tidyverse. So if you don't have a dataset to play around with, you can totally follow this tutorial. So if you're ready, let's dive in. Okay, so for those of you who have already watched my other tutorials, you know I like to clean up my environment in case there are hidden objects in the background, free up memory, etc. And now we will load the libraries we're going to use. Really the only ones you need are ggplot, which is included in the tidyverse, and or Color Brewer if you want to edit colors and stuff like that. Great. Next we will load the Biostat_Squid theme, which I will use to customize different things in my plots. I will go a bit into that later on. So for now, just ignore it. Okay, so let's start by importing the data. So we're going to be using this dataset called Iris. If you want to read more about it, you can call Iris just like this. This will tell you that this data is giving you measurements in centimeters of different variables, sepal length and width and petal length and width of 50 flowers from each of the 3 species of iris. So we can just call head to have a look at the top 6 rows of the data set. So here we have the column names and the species, and we can also find out how many flowers of each species. So that's 50 of each. So this is the test data set we're going to be using in this tutorial. Great. So as we saw, Violin plots are used to visualize the distribution of numeric data, and they're especially useful when you want to make comparisons of distributions between multiple groups. In this case, we want to plot the distribution of sepal width for each of the species. But before we plot anything, we will convert the column containing the category, so the species column, into a factor with as factor. Let's start by creating a basic plot. So we call the function ggplot, and we have to specify the data set, which is iris, and then we will specify the x-axis and y-axis. And we will put this in the aesthetics part of the function because, well, anything that has to do with actual variables from your dataset need to go into this aesthetics part, let's say. Okay, so x-axis will be species. We want to plot different species in the x-axis, and y will be the sepal width. And now the way it works, we just add a plus, and I like to add a new line, and we will call Violin. And this will give you a basic plot. So here it goes. If you run this line, it will already give you a Violin plot. You can also include inside Violin, well, different arguments. One of them is trim, which you might want to set to false if you don't want it to trim the ends of the Violin plot. Great. You can also use chord flip to, well, flip the Violin plots and have them the other way around. Okay, so in this next part we're going to talk about adding different stats to our Violin plots to make them a bit more informative. So one thing you might be interested in is adding the mean or the median as a point to our Violin plot. And we can do that fairly easily. So I'm just going to copy this part, and of course we add plus, and we can do this adding stat summary. So the function of this, in this case the y variable, is the mean. You can set it to median as well. We want a point, geom point, and then shape can be used to customize what you actually want displayed. So you can have a star or a diamond. So I think 21 is just a circle. We're going to find out. And then of course you can edit the size and even the color. So I'm going to set it to dark blue. So this should work. Let's have a look. And there we go. Here's our mean for each of the groups. We can also add a box plot. So we can do that by using geom box plot, and we can set the width of the box plot as well. So 0.1 for example. And if we run this, now we have a little box plot with each violin plot. So that can be very useful as well. Now, you might have seen also violin plots that just show the mean and the standard deviation as a line. And we can also add that using a crossbar or point range. Let me just show you how we do this. So again, we would copy this part. We now add stat summary, and now we're going to use the mean SDL. I'll talk about this more in my blog post, so if you want to read more about what this function means and what all the different arguments mean, just you can find the information there, but I'm going to set it to 1.5, the standard deviation, and I'm just going to use a crossbar, and we can also edit the width. Let's see, 0.2. So this should work. Okay, so as you can see, the mult parameter was ignored, so that was my bad. The way you actually specify the constant is by using function arguments. So I'll set this to 1.5. So basically this is computing the mean and standard deviation and multiplied by a constant, which is 1.5. So this should now work. There we go. Nice. So we can also, instead of crossbar, we can use point range. So if we use point range, we get something like this, which you have probably also seen. Great. And another thing we might be interested in is adding a jitter to our violin plot. So I'm just going to copy this again. We add plus geom jitter. So I'm going to use shape 16, which I think are filled circles, but again, feel free to play around with that. And then it's important to specify that you want it to be jitter points, basically. So I'm going to give it a constant. You can also play with this number to make the circles or the points more spread out or less. There we go. So this would be our jittered or our violin plots with jitter. Nice. So I guess the next step is to add some color to our plots. So I'm just going to take the basic plot. To add color, we just need to specify it in our geom violin part. So if we have col, we write col, we can set it to a specific color, for example, blue. And as you can see, editing the color just changes the contour of the violin plot. Whereas if we want to edit the actual, the inside of the violin plots, we use fill. So this would be to set fill or the contour to a specific color. Again, you might be interested in filling these by the species. Now, since species is part of our data frame, we need to define this within the aesthetics. So I'm going to delete this part, and inside aesthetics, I define fill, which will be species. So again, we use anything that has to do with the data itself goes inside the aesthetics. So now this should color our violin plots based on the species. And of course, you could color by something else if you have a different column in your data frame. So I'm going to set the color to black. And of course, we can also edit the line width. So how thick you want the contour. Let's see. There you go. Nice. So of course you might want to change or edit the actual colors of the violin plot. And we can do this in many different ways. One of the quickest way to edit colors is by using a predefined color palette. And this is why we loaded the Color Brewer package, which gives you different color palettes. So you just need to give it Scale Fill Brewer, and we can choose the palette we want. I'm going to give it dark 2. I will leave a link in the description, but you can Google this. There's many different color palettes, and yeah, you can decide which one you like best. So this will use the color palette dark 2, and as you can see, the colors are different. And again, if you wanted the color and the contour and not the fill, you would just say Scale Call Brewer. So sometimes we actually want custom colors. So we can do this in different ways, but one of the easiest ways, or the one I use the most, is by first defining a color dictionary. So to do this, we just define a list, and for each of the different species, I'm going to choose my color. So for example, this will be pink 2, turquoise, orange. Nice. So again, we will copy this. So we run this line and we have our color dictionary here. And now, instead of Scale Fill Brewer, we just have to use Scale Fill Manual. And the values will be the values defined in our color dictionary. So now they're colored by the colors we defined here. Nice. Okay, so you might be interested in editing your plot, for example, changing the plot background or editing the size or color of the labels or the titles. So everything in a ggplot object, or almost everything, is customizable. And you do this by editing the theme part of the code. First of all, let's add some titles to our plot. I'm just going to copy this for now. And we can add it really easily by using labs. So labs will add a title, and then we can also change the titles for the x-axis and the y-axis. So for example, sepal width in centimeters. Remember to use quotation marks since it is text or a character string. So this will add title and it will change the labels. That's a very easy way of doing it. Now, you might be interested also in changing the legend position, for example, as well as other theme options. So first of all, the easiest way of changing the overall theme or look of the entire plot is with different functions of theme. It's most easily edited by using theme, and then there are many themes that ggplot offers, as you can see, so you can play around with these and see which one you like best. So for example, theme black and white will change how the plot looks, or you can use theme classic, which will change how the plot looks overall. So I'm going to use black and white for now. So you can use that as base and then just edit different parts of the plot you want to, well, change further. For example, the legend position. So if we want to change something like the legend position, we can just add a plus and then theme. And then inside theme, separated by commas, you can use different things you can edit. So I'm going to just show you here. So these are all the components of the theme you can edit. So axis ticks and the axis text and so on. So anything that has to do with the size or the color or whatever it is, you just edit it here. So for example, legend position equals bottom. And now we have our legend position in the bottom. So it's actually easier to just, whatever it is you want to change, just kind of Google it, and then you'll get the exact line you need to change. Obviously, it's very difficult to kind of memorize absolutely everything. Another thing you can change in your plot is the aspect ratio. So if we change it to 0.2, or let's say 0.6 maybe, it will just make the plot a bit more kind of elongated. So I don't recommend using this screen to know how the plot will look at the end. It's maybe sometimes more informative to zoom or to just save the plot. So for example, an aspect ratio of 0.6 would look like this. An aspect ratio of 2 will look like this, so a bit more compressed, as you can appreciate. Another thing you can change is the axis text and the titles, of course. So we can do that. I'll just keep adding commas here, might be easier. So axis text, axis.text is an element text. And now inside element text, you can add whatever it is you want to change. So size equals 12. I'm going to make it bold. And I'm just going to use, I don't know, purple, for example. And we can also change the label, the title. So I'm going to just copy paste this line. Here we go. And instead of text, we just use label, make it bigger. And for example, we'll use dark blue. Okay, sorted. It is not axis label, but actually axis title. So now this should work. So we're going to remove this aspect ratio since we don't want it anymore. So as you can see, I changed the labels and the title of the different axes. If you just wanted to affect one, you can just add .x or .y. So now you can see it's only the x-axis that has species in dark blue. Nice. If you want to remove something, for example, the plot title, you can just, one way to do it is to assign it to element blank. So this should make it disappear. Or you can just set this, you can just remove it, remove this line, and then there will be no title. That's another way of doing it. Great. I tell you a bit more about the theme functions and all this in my other video, but one of the things that is very useful is defining a theme at the very beginning. So this is the ByStatSquid theme, and as you can see, it's the theme function, and then I added a lot of different things that define the entire theme of the plot. So instead of having to add, where were we? Around here. Instead of having to add this block to all my plots, I can just take the main function. So it would be this, and then just add plus ByStatSquid theme. And this changes the entire theme, I guess, of the plot. Okay, so back to our plotting. Sometimes we might be interested in plotting different groups, but also different, let's say, subgroups within each group. So for example, we might be comparing different groups of mice, and some have been, some are control mice and some are diabetic mice, for example. So we want to show these different groups. I'm just going to create a fake column, in this case, called treatment, which will just contain treated or untreated for just randomly, just to have an additional column to group our flowers by. So there we go. We have a new column that just has treated and untreated and so on. So now I want violin plots for each of my species, but within each species I want a separate violin plot, a grouped violin plot for based on the treatment. So we can do that very easily by using the function fill, just as we learned. This time we are using species in the x-axis, but we're going to fill by treatment. And a thing we need to edit is the color dictionary, because before we used a color dictionary that was specific to the species, And now we need to make it specific to treated. Nice. So this is what I meant, right? You have the different species in the x-axis and then treated, separated by treated and untreated. So that makes it a bit easier to compare. Great. So this is one way of doing it. I didn't mention, if you don't want to define the different groups, you can just use a color dictionary that just has kind of a list of colors, and that will work too. But then the colors are just used in order. You don't have any kind of control over what is colored with what color. Nice. So that was kind of it for multiple grouping. Now, sometimes we might be interested in plotting many different variables. For example, if we go back to our data set, we have many different columns we might want to plot. So not only sepal width, but petal length and petal width and so on. So we can just copy paste this chunk of code and just change the y-axis, but sometimes you just have too many columns. So I'm going to show you two ways of getting a lot of Violin plots for many different variables in an easy way, or easy-ish way. We'll leave that for the next video, but this is it for today. Squid-tastic! If you're interested in more ggplot tips and tricks, like saving plots and customizing them, I already have a video which may be useful to you. Otherwise, thank you very much for watching. If you're new here, don't forget to subscribe. Let me know what you thought of this tutorial, or if you have any more suggestions on new topics. Remember, you can also vote at biostatsquid.com. Have a squid-tastic day and see you in the next one.